Okay, thank you. Hello, my name is Yuji Sasaki, and I am a student at Keio University in Japan. I will make a presentation about the effect of students' prior programming experience on promoting algorithmic thinking using binary tree learning system. Our previous studies show that classification lesson using a binary tree or decision tree is useful in cultivating algorithmic thinking. Today, I will talk about the effect of student prior programming experience, including visual programming to the classification lesson. Algorithmic thinking and computational thinking is important keyword in this study. Computational thinking has many definitions. We are using Ring's definition. According to it, computational thinking is a process of thinking that expressing problems and their solutions in executable way by computer. In education, it is not only a process of thinking, it extends to a set of problem-solving methods. Algorithmic thinking is a part of concepts of computational thinking. It is to develop a step-by-step process to solve the problem. It means that algorithmic thinking is related to procedural tasks. Some of you may think that coding or visual programming help cultivating computational thinking, so we don't need to try figure classification. However, figure classification is very easy to elementary school students or, of course, another grade of students because figure classification has already been a part of primary education. Elementary school students experience figure classification in mathematics class, and they learn relationships between shapes. In addition, Venn diagram can help cultivating computational thinking, excluding algorithmic thinking. That is decomposition, abstraction, and pattern recognition. On the other hand, binary tree or decision tree is not used at math class, but it helps classifying procedurally, so it can cultivate algorithmic thinking. That is shown in our previous studies. As described, binary tree is useful in cultivating algorithmic thinking, and it was shown in our previous research. So we developed learning material using binary tree to cultivate algorithmic thinking. Previous studies have shown that students' algorithmic stu- students' algorithmic thinking skill improved before and after using this system. In this study, we examined the effect of students' prior programming experience to the skill improvement. This is an activity model. We asked students to complete task 1 to 5. Task 1 and task 3 is for confirm the student's understanding of figure classification using Venn diagram. Task 2 and task 5 is same material. Students describe freely in blank sheet. We score them based on completion of the proceduralization and compare. Task 4 is our proposed method. Students uh, class, classify, classify figures uniquely using the binary tree learning system. These are the problems that we set. These 9 shapes on the right are classified in both problems. And in task 1, we show the Venn diagram on the left to students. The difference of task 1 and 2 is if students have to classify them in the way that each figures are identified. These are web applications that we developed as learning system. Venn diagram learning system on the left is used in task 3, and binary tree learning system is used in task 4. Using binary tree learning system, student can choose classification condition and figures from left window and make binary tree. This system has automatic validation, which can check if the binary tree is correct or not. Here, here I show an evaluation method. We scored task 2 and task 5 as computational thinking skill level. 3 members scored each by themselves and took the average. We conduct the experiment for 11 students, and this is the result. Some student has coding programming experience or visual programming experience, and other students don't have programming experience. Our system can use for students who can classify using Venn diagram, and all students pass the Venn diagram test. Score 1 expresses the algorithmic thinking score before using our system, and score 2 expresses the score after using our system. Comparing score 1 and 2, the score 2 is better than score 1 for all students, and there is no difference between students with programming experience and inexperienced students. In addition, it didn't matter whether the classification using binary tree learning system is successful or not. It means that it is important to use the system, not to get success. The results shows that algorithmic thinking scores of all students were significantly improved. Also, the answer time of post-test was shorter than pre-test. In other words, changes in computational thinking score were related to before and after, but not to any programming experiences. In conclusion, therefore, it is unnecessary to consider the prior programming experience when conducting CT training using binary tree. In the future, we need additional experiment for more students and find factors other than programming experience that affect computational thinking. Thank you for listening.